One of the problems in traditional or wet chemistry is that you have to destroy something in order to understand it. For example, if you want to analyze something, then you would have to take a bit of that sample, put it in a test tube, use chemicals, and then you won't be able to use the sample after that. So you are basically destroying the sample. And aside from that, you are adding chemicals which are usually toxic to the user and to the environment. I came here to New Zealand because the group I am working with are experts in this technique called vibrational spectroscopy. This technique is very useful because it could be applied to almost any type of sample. It is fast, it is non-destructive, it is so very efficient that it is just like scanning barcodes in the supermarket. In vibrational spectroscopy, basically you shine a laser onto the sample. This causes vibration or change in vibration to the molecules of the sample. So each specific molecule has its own way, unique way of vibrating, resulting to a unique spectrum. So each spectrum acts as a fingerprint to the molecule. There are so many applications with this technique. We've worked with meat and dairy industry, analyzing old paintings at museums. In medicine, it can also be used as a laser probe to be inserted inside the body to monitor diseases such as coeliac disease. One of the projects I am working on is lake snot. It's called lake snot because it looks like one. It is green and it is slimy, and it is invading our New Zealand lakes. It is sticking to swimmers. It is clogging the fishing lines and the boat inlets. Even worse, it has also been found clogging a water screen of a hydroelectric power plant found in Lake Tekapo, and that is a big and costly problem. We don't know anything much about lake snot. We don't know why it is here, what's causing it to appear, how to get rid of it. It is very peculiar because it is invading clean lakes rather than other less clean lakes which are expected to be conducive for algal blooms. So it's very, very weird. In order for us to get rid of it, we must first be able to understand it. And that is what our team is trying to do. We are going to develop a sensor that will monitor the lake snot in its natural state. This project is really important because it could add $200 million annual profit to the New Zealand meat industry just after 16 years. The aim of the project is to develop a sensor technology that could analyze the meat quality in a non-invasive way. We want to develop a robot that could sit in the meat processing plant and analyze the meat while it is being processed. Dodd-Walls has helped me collaborate with people from different fields and different places across New Zealand. It has granted me scholarship so I could pursue my PhD studies. So basically, without Dodd-Walls, I won't be able to enjoy my having a PhD.